Hello friends, now we'll start the next exercise. Exercise 7.6. Limit of exponential and logarithmic functions. We use the following result without proof. Limit x tends to 0, e raised to x minus 1 upon x is equals to log of e, and the value of log of e to the base e is 1. Therefore, this is the important result, that is the limit x tends to 0, e raised to x minus 1 upon x. The value of this limit is 1. Now next, there is one more examples to the explanation for this formula. Limit x tends to 0, e raised to 5x minus 1 upon x. That is equals to limit x tends to 0. But we have the standard result, e raised to x minus 1 upon x. That is the exponent of this e and the divided by the same quantity. They must be the same. That is e raised to x minus 1 upon x. But here is a 5x and we have only the x. Therefore, we adjust here 5. We multiply to the numerator and the denominator by 5. Now the value of this limit is 1. 1 into 5 is 5. Therefore, this is the important. This is our basic result now. The value of this result is 1. And that's why the value of this limit is 1 into 5. Now next, limit x tends to 0, a raised to x minus 1 upon x is equals to log of a, where a is a rational number, is not positive rational number and is not equals to 0. A is any positive rational number. For example, now see this example. Limit x tends to 0, 5 raised to x minus 1 upon x is equals to log of 5. The same result, a raised to x minus 1 upon x is equals to log of a. In the same manner, limit x tends to 0, 5 raised to x minus 1 upon x is equals to log of 5. Now here see this result, that is limit x tends to 0, a raised to 2x minus 1 upon x. What is the exponent of a is 2x. Therefore, this quantity must be divided by 2x. Therefore, we write here limit x tends to 0, a raised to 2x minus 1 upon 2x into 2. The value of a raised to 2x minus 1 upon 2x is 2 times log of a, and that is equals to 2 log a. Limit x tends to 0, 1 plus x and whole bracket raised to 1 upon x. The value of this limit is 1. This is also very important result that you have to remember. All these results are without proof. Now see this here, the 1 plus x. Therefore, we here required the reciprocal of this quantity. That is, the reciprocal of x is 1 upon x, and that's why we use here, that is 1 plus x raised to 1 upon x. The value of this limit is e. Now next is the corresponding example is that, now see this, limit x tends to 0, 1 minus x and bracket raised to minus 1 upon x. The same thing is here, that is minus x, and reciprocal of minus x is minus 1 upon x, and hence the limit of this function is e. Next, limit x tends to 0, 1 plus 2x bracket raised to 1 upon x. Now here the exponent must be 1 upon 2x. Then the value of the limit is 1. But here is 1 upon x. Therefore, we'll adjust here 2. See this? Therefore, the value of this limit is 2. The value of this limit is e square. Sorry. Now here is limit x tends to 0. 1 minus 3 by 2x. Here we must require the reciprocal of minus 3 by 2. Minus 3x upon 2. Now what is the reciprocal of minus 3x upon 2? Is a minus 2 upon 3x. Now see this here. Limit x tends to 0. Now here I write in this manner. What is the coefficient of this x? The coefficient of this x is also minus 3 by 2, and hence the answer is e raised to minus 3 by 2. This is also very important result, that is a limit x tends to 0. Log of 1 plus x upon x, that is equals to 1. That is this is a log of x, limit x tends to 0, log of 1 plus x upon x, that is equals to 1. Next is limit x tends to 0, log of 1 plus 5x upon x. Now what is the coefficient of x is here? The coefficient of x is, that is the final answer. It means that we have to adjust here 5 to denominator and multiplied with by 5. The minus 3. Fifth, limit x tends to 0. E raised to px minus 1 upon px is 1, where p is a constant. Limit x tends to 0. A raised to px minus 1 upon px is log of a, where p is a constant. Limit x tends to 0, log of 1 plus px upon px is equals to log of that is equals to 1, where p is a constant. These are all the important result, that is the limit x tends to 0, 1 plus px, and the whole bracket is to 1 upon px, and that is equals to e. Now we'll start the exercise 7.6. Evaluate the following limits. The first is limit x tends to 0. 9 raised to x minus 5 raised to x upon 4 raised to x minus 1. Now this is of the form a raised to, limit x tends to 0, a raised to x minus 1 upon x. This type of the example. Now see this here. Divide the numerator and the denominator by x. Limit x tends to 0, 9 raised to x minus 5 raised to x upon 4 raised to x minus 1 upon x. But we require the standard form. Which is the standard form? A raised to x minus 1 upon x. In the same way, 9 raised to x minus 1 upon x, that type of the standard form. That's why we are adjusting here 9 raised to x minus 1. At the same time, this minus 1 is balanced by the plus 1. Therefore, now see this again. The whole divided by x, 4 raised to x minus 1. The denominator is adjusted factor and its answer is a log of 4. But for the numerator, we have to adjust plus 1 and the minus 1. Limit x tends to 0, 9 raised to x. Take the minus sign common from these two elements. If you take the minus sign common, then in bracket you will get 5 raised to x minus 1. That is a 9 raised to x minus 1 upon x minus 5 raised to x minus 1 upon x upon 4 raised to x minus 1 upon x. Therefore, you will get, that is a log of 9 minus log of 5. The whole divided by, therefore, what is the answer for this? Log of 9 minus log of 5 upon log of 4. Log of 4. That is, there must be the 4. By mistake, I had written there is a therefore log of 9 minus log of 5 upon log of 4. Now here is a subtraction for these two log. Therefore, by using the rules of the logarithm, that is, we can write log of 9 upon 5 whole divided by a log of 4. Therefore, 1 upon 4, 1 upon log of 4 into log of 9 by 5. And this is the answer. Next is limit x tends to 0, 5 raised to x plus 3 raised to x minus 2 raised to x minus 1 upon x. Now, to solve these type of the examples, that is the limit x tends to 0, 5 raised to x minus 1 we required, 3 raised to x minus 1 we required. But now we'll see how I had adjusted, how to adjust. Limit x tends to 0, 5 raised to x minus 1. Now see this here, 5 raised to x minus 1. But originally we have only one thing. See this first. What I had done here, 5 raised to x we required minus 1 plus 3 raised to x, and again this is a minus 1, but 1 minus 1 is extra there, which is minus 1. This minus 1 is extra there. This minus 1. Now this minus 1 is balanced by this plus 1, and originally this is our minus 1 and it is as it is here. Therefore, but we required in the standard form, which is the standard form, a raised to x minus 1 upon x. The answer is log of a. In the same manner, here is a log of 5, log of 3, and take the minus 1 minus sign as a common. Then you will get 2 raised to x minus 1. That is a log of 2. Now split up this. Limit x tends to 0, 5 raised to x minus 1 upon x minus. See this here. That we have, that is a log of 5 plus log of 3 minus log of 2. That is the multiplication of these two numbers, 5 into 3. That is a 15. That is again the sign between these two is a 5 into 3 is a 15, and the sign between these two is a minus. Therefore, whenever there is a minus sign, we divide. That is a log of 15 upon 2. L is equals to log of 15 upon 2. This is the final answer. Now see the next example. Limit x tends to 0, a raised to x plus b raised to x plus c raised to x minus 3 upon sine of x. Now, every time if you have the number of the time practice, and by seeing the examples, you will get the idea. That is the how to solve the example. That is, in this case, we required sine of x upon x. Therefore, by observation, we can directly say that divide numerator and the denominator by x. But again, we required the a raised to x minus 1, b raised to x minus 1, plus c raised to x minus 1. And we have minus 3 there. Therefore, minus 1, minus 1, minus 1 is distributed for these two, a, b, c. Now, see this. Now, for this problem, that is, we divide numerator and the denominator by x. That is, divide numerator and the denominator by x. Therefore, a raised to x minus 1 plus b raised to x minus 1 plus c raised to x minus 1 upon x. This minus 3 is balanced like this. Minus 1, minus 1, minus 3. We divide the numerator by x and the denominator, which is the sine of x upon x. Now here we can write that is the limit x tends to 0, a raised to x minus 1 upon x plus b raised to x minus 1 upon x plus c raised to x minus 1 upon x. The whole divided by sine x upon x. Now the value of this limit is log of a plus log of b plus log of c. The whole divided by 1. Therefore, the sum of the logs, that is the log of a plus log of b plus log of c, is nothing but the log of a into b into c. Therefore, L is equals to log of a, b, c. And this is the final answer. I will see the next example. Example number 4. Limit x tends to 0. 6 raised to x plus 5 raised to x plus 4 raised to x minus 3 raised to x plus 1 upon sine x. Now again by the observation, that is this sine of x required x to their division, their denominator. Therefore, divide the numerator and the denominator by x. Then we will adjust for each term minus 1 and minus 1. Now how we can write this? See this here. Limit x tends to 0, 6 raised to x minus 1 plus 5 raised to x minus 1 plus 4 raised to x minus 1. Now see this. This is the important step. That is 6 raised to x minus 1. That will be required. 5 raised to x minus 1. That is also will required. 4 raised to x minus 1. That is also will required. Minus 3 raised to x plus 1. Now this 3 raised to x plus 1 can be written as 3 raised to x into 3 raised to 1. But again, one thing is that there is a minus 1, and minus 1. That we are taking the extra. That is, to balance this, we add here plus 3. Now, see this here. All these minus 1, minus 1, minus 1. These are balanced by this plus 1, plus 1, plus 1. The next is all these upon sine x. This is the first part. This is the important. All these minus 1 are balanced by this plus 1. Now in the next step, that is the limit x tends to 0. 6 raised to x minus 1 plus 5 raised to x minus 1 plus 4 raised to x. That is. Now this is 1 plus 1 plus 1. That is a 3. Take minus 3 as a common. Then in bracket you will get 3 raised to x minus 1. Then in bracket limit x tends to 0 plus 5 raised to x minus 1, 4 raised to x minus 1 minus 3. Now this is it. Upon sine x. That is, from all these terms, we take this. Now, next is therefore, now divide the numerator and the denominator by x. Therefore, you will get 6 raised to x minus 1 plus 5 raised to x minus 1 plus 4 raised to x minus 1. That is, we divide first of all to the numerator. And now we will divide to the denominator sin of x upon x. Therefore, sin of x upon x. That is, the limit x tends to 0, 6 raised to x. That is a split of this 6 raised to x minus 1 upon x plus 5 raised to x minus 1 upon x plus 4 raised to x minus 1 upon x minus 3 in bracket 3 raised to x minus 1 upon x. Therefore, the value of this limit is a log of 6 plus log of 5 plus log of 4 minus 3 log of 3 upon 1. Upon 1. Now again this can be written as, this is the log of 6 plus log of 5 plus log of 4. That is the log of 6 into 5 into 4 minus 3 log of 3. That is, again this can be written as log of 120 minus log of 3 raised to 3. And log of 3 raised to 3 is a 27. And therefore, log of 120 upon 27, that is equals to log of 40 upon 9. And hence, the answer is log of 40 upon 9. Now we'll see the next example. Limit x tends to 0, 8 raised to sin x minus 2 raised to tan x upon e raised to 2x minus 1. Now again, this is of the form to the numerator, that is a raised to x minus 1 upon x, this form. This is also the same form. And next is e raised to x minus 1 upon x. Now we'll see here how to solve that. 8 raised to sin x minus 2 raised to tan x upon e raised to 2x minus 1. Now first of all, we will divide numerator and the denominator by x. Now, how I adjust? Now see this here. Limit x tends to 0, 8 raised to sin x minus 2 raised to tan x upon x, e raised to 2x minus 1. What is here? 8 raised to sin x minus 2 raised to tan x and whole divided by x, e raised to 2x minus 1 upon x. Limit x tends to 0, 8 raised to sin x minus 1 minus 2 raised to tan x plus 1 upon x, e raised to 2x minus 1 upon x. This is the important step. Now here we have adjusted minus 1 at the same time. It's a balanced by the plus 1. Now from these two terms, we will take as a minus sign as a common. If you take the minus sign common, then you will get 2 raised to tan x minus 1. Therefore, now see this again here. That is, limit x tends to 0. 8 raised to sin x minus 1 minus 2 raised to tan x minus 1 upon e raised to 2x minus 1 upon x. That is, we divide n and d by x. 8 raised to sin x minus 1 upon x minus 2 raised to tan x upon x. This is the first part. But the exponent of this 8 is a sin x and exponent of the 2 is a tan x. Therefore, we require the same function to the denominator. Now, next is 8 raised to sin x minus 1 upon sin x. Same thing is here. And it is a balanced by multiplied to the numerator by the sin x. This is important. That is here 8 raised to sin x minus 1 upon x can be written as 8 raised to sin x minus 1. It is divided by x. This divided by sin x is balanced by multiplying to the numerator sin x, and this is our x. Minus the same thing is also here 2 raised to tan x minus 1 upon tan x into tan x upon x. Now again there is 2 raised to tan x minus 1 upon tan x into tan of x upon x. Therefore, this whole divided e raised to 2x minus 1. That is here we adjust to the denominator is a 2. Therefore, exponent of e raised to 2x is 2x. Therefore, here we require the 2. Therefore, it is a balanced by multiplying to the numerator by the 2. Now we see the limits. That is a log of it. First of all, the answer of this is log of it. As x tends to 0, sin of x also tends to 0. By using that into 1, the value of this limit, that is a sin of x upon x is 1. Next is the value of this limit, that is a, here is a value of this limit is a log of 2 and the value of this limit is a 1. Therefore, next is now again the e raised to 2x minus 1 upon 2x, the value of this limit is 1, 1 into 2, and also we write here as x tends to 0, tan of x tends to 0, sin of x tends to 0. Therefore, the answer is log of 8 minus log of 2. Now, these are two separate quantities, that is log of 8 minus log of 2 upon 2. And it can be written as the subtraction between the two logs, that is the log of m minus log of n is equals to log of m upon n. And that's why it's written as like this, 8 upon 2, that is a log of 4. And now this 1 upon 2 will go to the exponent of the 4, that is a log of 4 raised to 1 upon 2, that is the square root of 4, which is the log of 2. Therefore, the answer of this is log of 2. Next is question number 2. Evaluate the following limits. Limit x tends to 0, 3 raised to x minus 3 raised to x plus 3 raised to minus x minus 2 upon x tan x. Now, again, this is very important and the famous problem. Now, to solve this limit, that is x tan x, that is this tan x will require the tan x upon x. But here is one more extra is there, extra is there. That is the we must require this tan x, that's to the numerator and denominator divided by x square. This will be the key factor for this. But here we will require the square term, then and then it will be the solve. Now see this, how it is adjusted, numerator That is the limit x tends to 0, 3 raised to x plus 3 raised to minus x minus 2 upon x tan x. That is the 3 raised to x plus 3 raised to, this is 3 raised to x, 3 raised to, it can be written like this, 3 raised to x plus 1 upon 3 raised to x minus 2. Now simplify this, 3 raised to x bracket square plus 1 minus 2 into 3 raised to x upon this whole divided by 3 raised to x. This is the simplified form. That is a 3 raised to x multiplied the whole polynomial, this expression by the 3 raised to x. It becomes 3 raised to x bracket square plus 1 minus 2 into 3 raised to x. Now this is a perfect square. That is a 3 raised to x minus 1 whole square upon 3 raised to x. 3 raised to x minus 1 bracket square upon 3 raised to x. Therefore, limit x tends to 0. 3 raised to x upon x tan x. That is the limit x tends to 0. 3 raised to x minus 1 bracket square. This is the important. That is, we have substituted the value of 3 raised to x plus 3 raised to minus x minus 2. Its a value comes to 3 raised to x minus 1 bracket square upon 3 raised to x. And this is the x tan x is as it is. Now here we will divide numerator and the denominator by x square. That is, divide n and d by x square. Therefore, limit x tends to 0, 3 raised to x minus 1 bracket square upon x square, x tan x upon x square into 3 raised to x. Now the value of this limit, that is a 3 raised to x. That is, as x tends to 0 means what? 3 raised to 0, and the value of 3 raised to 0 is 1. Therefore, limit x tends to 0, 3 raised to x minus 1 upon x and bracket square 1 upon tan of x. Now see this. That is x tan x upon x square. Now here x get cancelled. Then you will get tan of x upon x into 1 upon 3x. Now the value of this limit, that is a log of 3 bracket square into 1 upon 1. As x tends to 0, then you will get log of 3 bracket square. Therefore, the value of this limit is log of 3 bracket square. Now we see the next example. Limit x tends to 0, 3 plus x upon 3 minus x bracket raised to 1 upon x. Now this is of the form 1 plus x bracket raised to 1 upon x. But here we require the 1. Therefore, we will divide the numerator and the denominator by 3. Now see this here. That is 3 plus x upon 3 minus x whole raised to 1 upon x. Divide n and d by x. That is, after the dividing numerator and the denominator, divide numerator and denominator by 3. Therefore, it's written as limit x tends to 0, 1 plus x upon 3 upon 1 minus x upon 3 whole bracket is to 1 upon x. That is, the limit x tends to 0, 1 plus x upon 3 bracket is to 1 upon x. Limit x tends to 0, 1 minus x upon 3 raised to 1 upon x. Now, see this here. Therefore, limit x tends to 0, 1 plus x upon 3. The whole bracket raised to 3 upon x. But here is only the 1 upon x. Therefore, we will adjust 3 there. This is the 3 upon x and bracket is to 1 upon 3. That is, the limit x tends to 0, 1 minus x upon 3 and whole bracket is to minus 3 upon x is to minus 1 upon 3. Therefore, e raised to 1 upon 3, e raised to minus 1 upon 3. Therefore, that is e raised to 1 by 3 plus minus minus will become plus e raised to 2 upon 3. Therefore, the value of that limit is equals to e raised to 2 upon 3. Now next problem number 3. Limit x tends to 0, 5x plus 3 upon 3 minus 2x whole bracket is to 2 upon x. That is limit x tends to 0, 3 plus 5x and 3 minus 2x bracket is to 2 upon x. Now divide the numerator and the denominator by 3. Divide numerator and the denominator by 3. By mistake I have written by x, but it must be divide numerator and the denominator. That is, here divide the numerator and the denominator by 3. Therefore, you will get 1 limit x tends to 0, 1 plus 5x upon 3 upon 1 minus 2x upon 3 whole bracket is to 2 upon x. Now next we'll separate it. Limit x tends to 0, 1 plus 5x upon 3 bracket is to 2 upon x. Limit x tends to 0, 1 minus 2x upon 3 whole raised to 2 upon x. Now this is written as like this. See this here. Therefore, you will get, that is the limit x tends to 0, 1 plus 5x upon 3 whole bracket is to 2 upon x. Upon limit x tends to 0, 1 minus 2x upon 3 bracket is to 2 upon x. Limit x tends to 0, 1 plus 5x upon 3 bracket is 2. Now here, what is the reciprocal of 5x upon 3? The reciprocal of 5x upon 3 is 3 upon 5x. But we have only the 2 upon x. Therefore, we have to adjust 5 upon 3. Now, see this here. Into, now see this here. That is 1 plus 5x upon 3. 1 plus 5x upon 3. Now we write here like this. What we write? We write here. This is the term that we write here. That is a 3 upon 5x. Originally we have x here. It's a balance here. But we have new terms, that is a 3 upon 5. It's a balance by 5 upon 3. Again, one thing is remaining, which is that here is a 2. Now, to balance these two, we will write it like this. It is written as it is 2. Therefore, the value of this limit is 1. Then e, value of this limit is e. And e raised to 10 upon 3 to the numerator. In the same case, for the denominator also, limit of the denominator it is 1 minus 2x upon 3, and the reciprocal of this is minus 3 upon 2x, and originally we have 1 upon x. What are the next two terms? The next two terms that we have to balance, that is a minus 3 upon 2 is balanced by minus 2 upon 3 into 2. Now the value of this limit is e. Value of this limit is e raised to 10 upon 3, e raised to minus 4 upon 3. This is the first part. Next is therefore e raised to 10 upon 3 upon e raised to minus 4 upon 3. That is equals to e raised to 10 upon 3 minus this minus and minus will become plus. That is e raised to 14 upon 3. Therefore, L is equals to e raised to 14 upon 3. Now, the next problem is limit x tends to 0 log of 3 minus x minus log of 3 plus x upon x. Now, how I had solved this problem? This is very important. The first is I am applying the rules of the logarithm first of all. That is a log of m minus log of n is equals to log of m upon n. This is the first. When there is a subtraction sign between the two logs, then you will get log of 3 minus x upon 3 plus x and the whole divided by x. Therefore, limit x tends to 0. Log of 3 minus x again I am giving log of 3 minus x upon 3 upon 3 plus x upon 3. That is, divide this numerator and the denominator by 3 because what's the basic formula for this log? The basic formula is log of limit x tends to 0 log of 1 plus x upon x is 1. For that we require here 1 in place of 3. That is the limit x tends to 0 log of 1 minus x upon 3 1 upon x. Limit x tends to 0 1 upon x log of 1 minus x upon 3 minus log of 1 plus x upon 3. Now again I am splitting here. Now see this here. That is, this is the division and I am again applying the rules of the logarithm. That is 1 upon x log of 1 minus x upon 3 minus log of 1 plus x upon 3. Therefore, limit x tends to 0 log of 1 minus x upon 3 upon x minus log of 1 plus x upon 3 whole divided by x bracket complete. Now adjust numerator denominator, that is a minus x upon 3 and for this x upon 3. Therefore, it is written as like this. Limit x tends to 0 limit x tends to 0 log of 1 minus x upon 3 minus x upon 3. That is, we divide this x by minus 3. It is balanced by multiplying by minus 1 upon 3. 1 upon 3 minus log of x plus x upon 3 into 1 upon 3 bracket. Now the value of this limit, that is the limit x tends to 0, that is the written, that's log, this should be not there, that is the limit x tends to 0. Now next step is therefore the value of this limit is 1 into minus 1 upon 3 minus 1 into 1 upon 3. That is minus 1 upon 3 minus 1 upon 3, which is the minus 2 upon 3. Therefore, the limit L is equals to minus 2 upon 3. Next is limit x tends to 0, 4x plus 1 upon 4 upon 1 minus 4x whole bracket is to 1 upon x. Now it is written as like this. First of all, that is, we always required the form 1 plus x and bracket is to 1 upon x. In this way, we write here 1 plus 4x upon 1 minus 4x bracket is to 1 upon x. That is, limit x tends to 0, 1 plus 4x bracket is to 1 upon x, 1 minus 4x bracket is to 1 upon x, and therefore we'll adjust here 1 upon 4x. That is, the limit x tends to 0, 1 plus 4x bracket is to 1 upon 4x whole bracket is to 4 for the denominator. Limit x tends to 0, 1 minus 4x bracket is to minus 4x whole bracket is to minus 4. Therefore, you will get e raised to 4 upon e raised to minus 4, and that is equals to e raised to 4 minus in bracket minus 4. That's, you will get e raised to plus 8. Therefore, the answer is e raised to 8. Now, next is, as x tends to 0, 4x tends to 0, limit x tends to 0, 1 plus x raised to 1 upon x is 0. Now, next, problem number 6, limit x tends to 0, in bracket 5 plus 7x upon 5 minus 3x whole bracket is to 1 upon x. That is, limit x tends to 0, divide numerator and denominator by 5. Therefore, you will get limit x tends to 0, 5 minus 3x upon 5 is to 1 upon 3x. Limit x tends to 0, 1 plus 7x upon 5, 1 minus 3x upon 5. The answer of this is directly e raised to 7 by 5 and bracket is to 1 upon 3, and to the denominator e raised to minus 3 by 5 whole bracket is to 1 upon 3. You can write directly answer. That is, the coefficient of x is here 7 upon 5 bracket is to 1 upon 3, e raised to minus 3 by 5 bracket is to 1 upon 3, and then simplify. You will get the answer. That is, e raised to 7 upon 15 and e raised to minus 1 upon 5, and the answer is that is e raised to 10 upon 15, that is nothing but e raised to 2 upon 3. Now see this here, limit x tends to 0, 1 plus 7x upon 5 and bracket is to 5 upon 7x. Now we are adjusting here, that is a 7 by 5, and originally we have 1 upon 3. Now once again, see this here. Listen. That here one, we have 1 upon 3 and it is balanced by 7 upon 5. Therefore, this is the e raised to 7 upon 15. This is the first part. And to the denominator, limit x tends to 0, 1 minus 3x upon 5 raised to minus 5 upon 3 into 1 upon x. That is a minus 1 upon 5. Therefore, e raised to 7 upon 15 minus e raised to minus 1 upon 5. If we simplify this, then you will get that is e raised to 2 upon 5, 2 upon 3. Therefore, the limit is equals to, let's see the next example. Question number 3. Evaluate the following limits. Limit x tends to 0, a raised to x minus b raised to x upon sine of 4x minus sine of 2x. Limit x tends to 0, a raised to x minus 1 minus b raised to x plus 1. Now we'll apply the formula for sine of c minus sine d. That is a 2 times cos of c plus d upon 2 into sine of c minus d upon 2. Therefore, we will get that is a cos of 6x upon 2 means what 3x, and sine of 2x upon 2 that is a sine x. Divide the numerator and the denominator by x. We will carry the simultaneous the steps. I had taken the minus sign common from this, minus b raised to x plus 1. That is a raised to x minus 1 minus in bracket b raised to x minus 1. This is the 6x. Again, you can see here. It is written as split up it. That's the cos of 3x sine of x. Therefore, we take the limit for the sine of x upon x. The value of this numerator limit is log of a minus log of b upon one. That is a 1 upon 2 log of a minus log of b. That is 1 upon 2 log of a upon b. Again, there is a minus sign between these two logs. Therefore, it is a log of mod of a upon b. Therefore, 1 upon 2 log of mod of a upon b. This is the final answer. Formula for sin c minus sin d is a 2 times cos of c plus d upon 2 sin of c minus d upon 2. These are the formulas. That is it. Problem number 2. Limit x tends to 0, 2 raised to x minus 1 bracket cube upon 3 raised to x minus 1 into sin x into log of 1 plus x. Everything is adjusted. Now what is the 2 raised to x minus 1 bracket cube? Means here we will require, this term will require x cube. Therefore, again to the denominator 3 raised to x minus 1 upon x sin of x upon x log of 1 plus x upon x. It means that divide this numerator and the denominator by x cube. Divide n and d by x cube. Therefore, the limit x tends to 0. 2 raised to x minus 1 bracket cube upon x cube. 3 raised to x minus 1 into sin x into log of 1 plus x. These all are divided by x. Therefore, limit x tends to 0. 2 raised to x minus 1 upon x bracket cube upon 3 raised to x minus 1 upon x sin of x upon x into log of 1 plus x upon x. Therefore, now what is the value of this limit? Is a log of 2 bracket cube. Here is upon log of 3 into 1 into 1. Now see this here. Log of 2 bracket cube upon log of 3 into 1 into 1. Therefore, the answer is limit L is equals to x tends to that is a log of 2 bracket cube upon log of 3 must be there by mistake. I will again show you. That is a L is equals to log of 2 bracket cube upon log of 3. Now we'll see the next example. Now the example number 3. Limit x tends to 0. 15 raised to x minus 5 raised to x minus 3 raised to x plus 1 upon x sin x. By the observation, the denominator is x sin x. Means what? Denominator will require x, but here is x sin x. It means that divide numerator and denominator by x square will be possibility there. Now see this here, 15 raised to x means what? 5 into 3 bracket raised to x minus 5 raised to x minus 3 raised to x plus 1. Therefore, it is written as like this. That is limit x tends to 0. 5 raised to x into 3 raised to x minus 5 raised to x minus 3 raised to x plus 1 upon x sin x. Now divide numerator and the denominator by. Now first of all we factorize. Take the 5 raised to x common. Then in bracket you will get 3 raised to x minus 1 minus 1 3 raised to x minus 1. Therefore you will get limit x tends to 0. 3 raised to x minus 1 into 5 raised to x minus 1 upon x into sin x. Now here 3 raised to x minus 1 required 1x and 5 raised to x minus 1 required also 1x. Therefore, divide numerator and the denominator by x square. Therefore, limit x tends to 0. 3 raised to x minus 1, 5 raised to x divided by x square. It is written as like this, upon x square. Now, these two x get cancelled. Limit x tends to 0. 3 raised to x minus 1 upon x into 5 raised to x minus 1 upon x. X get cancelled. Sin x upon x. The value of this limit is log of 3 into log of 5 upon 1. Therefore, log of answer is log of 3 into log of 5. Keep this as it is because these are the multiplication of the two brackets. Therefore, log of 3 into log of 5. Next is limit x tends to 0. 25 raised to x minus 2 into 5 raised to x plus 1 upon x sin x. That is the limit x tends to 0. 5 raised to x bracket square minus 2 into 5 raised to x plus 1 x sin x. Now again here x sin x will require only the sin of x upon x. Therefore, divide numerator and the denominator by x square. That is a 5 raised to x minus 1 bracket square upon x sin x. Now divide n and d by x square. Therefore, limit x tends to 0. 5 raised to x minus 1 bracket square upon x square. X sin x upon x square. Then you will get Limit x tends to 0, 5 raised to x minus 1 upon x bracket square sin of x upon x. Therefore, the value of the limit is log of 5 bracket square upon 1. Therefore, the limit is log of 5 bracket square. These are the formulas that we required for this limit. Now next is limit x tends to 0, 49 raised to x minus 2, 35 raised to x plus 25 raised to x upon sin x into log of 1 plus 2x. Limit x tends to 0, 7 raised to x bracket square minus 2 into 7 into 5 bracket raised to x plus 5 raised to 2 bracket raised to x sin x into log of 1 plus 2x bracket complete. Therefore, limit x tends to 0, 7 raised to x minus 5 raised to x bracket square upon sin of x into log of 1 plus 2x. Now divide numerator and the denominator by x square. Therefore, you will get, that is the limit x tends to 0, 7 raised to x minus 5 raised to x bracket square upon x square upon sin x into log of 1 plus 2x upon x square. Now again this can be written as in the standard form, that is a 7 raised to x minus 5 raised to x upon x bracket square sin of x upon x log of 1 plus 2x upon x. Now adjust plus 1 and minus 1 to the numerator. That is a 7 raised to x minus 1 minus 5 raised to x plus 1 upon x. Seven raised to x minus 1 upon x minus 5 raised to x minus 1 upon x bracket square. And the denominator is a sin x upon x log of 1 plus 2x upon 2x into 2. That is a log of 7 minus log of 5 bracket square. 7 minus log of 5 bracket square upon 1 into 2. That is a log of 7 upon 5 bracket square upon 2. Therefore, it is equals to log of 7 upon 5 bracket square upon 2. And hence, the answer is similar types of the examples. That is 1 upon 2 log of 7 upon 5 bracket square. And in this way, we have completed the exercise 7.6. Now we'll see in the next video. Till then, goodbye.